Welcome back, mathematicians. Now, the reason I cut the video short and started another one is that this part of the preparation for our first exercise is actually extension material. So it should only appear on Extension 1 papers. And that is the ratio division formula. Now, the midpoint formula that we saw up above is a special case of this. So it turns up in 2 units, but what we're going to do is to look at dividing an interval up into any ratio at all. Now, as a simple proof, we shouldn't get asked to, well, we won't get asked to prove this, but the principles of the proof might come in handy in some other questions. So let's have a look at it. So if we've got P and Q, these 2 points here, and M is going to be something which divides PQ, so something which divides this thing in the ratio K to L. So this length, P to M, is K. This length, M to Q, is L. Now if we look at triangle PMS here, so this right angle triangle, and triangle MQT, these are similar triangles. We won't go exhaustively through the proof again because that's geometry, but they both have a right angle. This angle, because these lines are parallel, these are corresponding angles. So if we have 2 angles, then we have all 3 angles, and therefore our figures are similar. Therefore the ratio of corresponding sides is always the same. So PM to MQ is therefore the same as PS to MT, and that will therefore also be K over L. So then, if we look at what K over L actually is in terms of the X and Y coordinates, then the X's, X minus X1, so this distance here is K, and X2 minus X is L, and in terms of Y's, our Y minus Y1, the difference in the Y's, this bit here, must also be K, because all the sides have that ratio, and the difference in the Y's here must be L. So if we then make X the subject of this formula, so there's a nice little exercise for you. How do we do that? How do we make X the subject? So I'll give you a heads up that we would multiply that up, we would expand terms out, we gather them together, and we get to, if my pen works, we get to our expression for the X coordinate of the point M and the Y coordinate. So notice the structure of this here. So if this is K to L, we end up multiplying L by the X coordinate down here and K by the X coordinate up there, and we divide by the sum of L plus K. And likewise for the Y. So the L goes with the Y, which is on the other part, if you like. I'm trying not to use technical terms. And the K goes with the Y on the other part, and we divide it by L plus K. So this relationship is what we need to get our head around. You can see that if this was a 1-to-1 ratio, and we were talking about the midpoint, it would just be x1 plus x2 divided by 2, y1 plus y2 divided by 2. So the midpoint formula is contained in this, but this is more general. So this formula that we've just looked at is concerned with dividing a line internally and giving us a point M between P and Q. So again, the K gets multiplied by the coordinates of Q, the L gets multiplied by the coordinates of P, divided by L plus K, and we get a point which is in between. So that's internal division in a ratio. However, it's possible to use this very same formula to divide an interval externally. So in this case, point M is outside the interval PQ, which means it's either beyond P with the line PQ produced to the left, or it's beyond Q with the line PQ produced to the right. So the technical way of saying that is if it's on the left, that's QP produced. If it's on the right, it's PQ produced. So if I take the ratio as being K to L for an external division, then I go K this way and L across this way. So I multiply the coordinates of Q by K, and then I multiply the coordinates of P times L, and because I'm changing directions here, the ratio is taken as a negative, and it doesn't really matter which one I take as the negative. Now for me, logically I would take K as negative because I'm going to the left and L as positive, but it makes no difference to your answer. So if the size of K is less than L, as it clearly is in this diagram here, the point M is on QP produced, and if the size of K is greater than L, then I'm on PQ produced. And in this case, again, the ratio is negative. That should be an L just there, not a K. So the ratio is negative, and for me, I would take K as positive and L as negative, but it doesn't matter. Let's have a look at these examples here. So M is going to divide the interval A to B in the ratio given below. Draw a diagram and find in what ratio B divides AM. I don't think that makes any sense, does it? So this question is not what I was hoping for at all. So we'll just do one or two of them, and then we'll move on to have a look at some others. So if AM is to MB, so we've got A, M is dividing the interval AB, so A to M, M to B, that's a 1-to-1 ratio. It then says find in what ratio B divides AM. So if B divides AM, then this is now saying, I'll just change pen colour. If B is dividing AM, this is now an external division. So that means that, and it's beyond M, so that means we're going out here and back to M. So it's an external division in the ratio of 2 to 1, and it's a negative ratio. And as I said before, I would take that as the negative. So we're back after that slight technical hitch. Note to self, keep the computer plugged in. Now, this is not a great question, and this textbook doesn't do dividing the ratio in an interval very well at all. So I've got questions down here from 5A. They should very, very comprehensively cover the advanced part of the work. You may want to be a little bit selective if you're finding them really easy early on and just go to some of the later ones. But I do want to get some questions to do with the extension part, so I've just added those below. I'll scroll there now. These are out of another textbook called, or written by Margaret Grove, called Maths in Focus. She does some things well, but she's got some good questions in here, so I'll get you to work through them. But again, be selective. She goes for a little bit of overkill, I think, on the just straight out drill questions. So I'm just going to do 3 examples out of question 2 here about division of lines externally, just so that we've got something to work with. And then, as I said, just do a few out of number 1, the internal divisions. Until you get your head around the external divisions, I would keep doing questions out of number 2, and then follow through and just do a selection from later on. So I will just do A and C from here. I do think you'll be right, or maybe I should do one of these as well. So if I do I, just because it's on the screen, where I'm dividing this interval internally in the ratio of 4 to 3. Now, the only problem with Margaret Grove's book is that she has an annoying habit of, I think, writing these points, which is not how they would look on the number plane. This one would be further to the left, this one would be the one on the right. And I guess the reason she's trying to do it is that if you call this point A and this point B, then that tells us that we have to do things in a certain order. But to me, it's more logical to go left to right. So I really, when I do my little picture, I find it really hard to just accept and to write things in what I think is the incorrect order. But I need to do that to get the answers that she's got in the book here. So if we're dividing this in the ratio of 4 to 3, 4 parts there and 3 parts there, then to get our x value, we're just going to say that x is 4 times negative 3 plus 3 times 2, all over 4 plus 3 is 7, which is going to give us minus 12 plus 6 is minus 6 on 7, and our y value will be 4 times negative 1 plus 3 times 2, 4 times negative 1 plus 3 times 5 over 4 plus 3. So that will give us negative 4 and 15, so that's 11 on 7. Okay, so let's have now a look at dividing intervals externally. So the thing about the external division is that, and again, I just have to make sure I do it. Now this one actually makes sense to me, minus 2, 3 and 6, 1. So I know that when I divide externally, then my ratio is going to be negative. And again, I said that I've got this funny little quirk of making things that go to the left negative and things that go to the right positive. So I'll just change pen colour because I think things are going to get a bit crowded here. So I'm dividing in the ratio 1 to 5. So in our notes we saw that if the first number is the smaller, then the interpretation is that we go this way and then this way. So we're actually getting bombarded with messages. No, we're actually going before the line. We're producing it back towards the left. So I would call that minus 1 and this 5. Now, in that case, the 5 gets multiplied by this lot, and the minus 1 gets multiplied by this lot. So therefore, my x value is minus 1 times 6, minus 6, plus 5 times minus 2, which is minus 10, over 5 plus minus 1, which is 4. So that gives me minus 16 on 4, which is minus 4.5. And my y value is going to be minus 1 times 1 plus 5 times 3 over, what, that didn't change to 4. So that was a 4, so we've got 14 on 4, which is going to be 3.5. Now if I just do C, really squeeze it in here, we're running minus 1 to 1, minus 1, 1, sorry, to 4, 7 over here somewhere, and we're dividing it externally, so our point is going to be beyond this line, and it's a ratio 4:3. So I've picked this one obviously because the first number is bigger. So in that case, my interpretation is, and again I'll change pen color, that starting on this left-hand end, I go 4 out and 3 back, and clearly it's not to scale. And again, I could make either one of these the negative because our ratio has to be negative, but to me it makes more sense to go with that. And then we set up our formula. So, and the 4 is going to get multiplied by this, and the -3 by this one. So I've got -3 times -1 to give us 3. 4 times 4, 16, and that's over 4 plus minus 3, which is 1. So my x value is 19, and my y value, got -3 times 1 to give us -3, and 4 times 7, which is 28, and that's all over 1, so that will give us 25. So my point out here for the external division should be the point 1925. So if you now like to continue working through these, as I said, that ratio division is the extension 1 part. It's rarely come up in extension 1 exam, as you'll see, until last year. I don't know what that means, whether they'll try it again next year or not.